can see that we use the same IP address, but we got different subnet masks because of the CIDR notations. This one is /27 and this one is /15. In this video, I'll be showing you how to find the subnet mask of a given IP address. In this case, we are given the IP address 192.168.1.20/27. The address is divided into two parts: the network ID and the host ID. The network ID is the one whereby all the devices in that particular network have in common, and the host ID is different, is unique to each device. So here, in finding the subnet mask of this one, we are told that out of the 32 bits, because every subnet mask have 32 bits, but we are told all the 27 belong to the network and the remaining 5 belong to the host. So to find it, let's go by writing all the 32 bits. This is 8. If you count all this here now, we have 32 bits, but we only need 27 for the network ID. Here we have 32 bits into 4 octets. So every subnet mask is divided into 4 octets and total of 32 bits. Octet comprises of 8 bits. So this 8 here is 1 octet, another 8 here, 2 octets, 3 and 4 here. So we are now looking for 27 bits which belong to the network. So we have 8 here, 16, 24, then 25, 26, 27. These ones I highlight here now are the ones belonging to the network. Let me highlight them to make it a bit different. Okay, you can see all these red ones here are the network bits, and the remaining 5 are the host bits. If you want to write them in binary now, let me now write it in binary. We have remember we need 27, then 1, 2, 3. This is 27, and the remaining 5 will be 0 because the totals will be 32. The total is 32 bits. So if 27 belongs to the network, which we write as ones, the remaining, we have 5 remaining for the host, making it a total of 32. To convert these binaries into actual numbers, anyway, in any octet you see all the ones are turned on, consider it as 255. The total is 255. To those that don't understand how we got the 255, you got it from this number here, 128. If you divide it by 2, you got 64. Any number we have, we divide it by 2 until we reach 1. So 64, we have 32, we have 16, we have 8, 4, 2, and 1. So if you count these numbers individually, we have 8 numbers here, each of which correspond to the ones you are seeing in this octet here. The first one here is equal to 128. The second one is equals to 64. The third one is equals to 32. Coming up to the end, the last one here is equal to 1. So if you add all these numbers combined, you get 255. So that is why in any octet you see all the ones turned on, consider it as you add all these numbers, whereby you get 255. So here now, this first octet we have 255. Sorry. Then we move to the second one. The second octet here also, all the ones are turned on, so that is 255. We come to the third octet here, all the ones are turned on also, 255. Then when we come to the fourth one, this is the interesting one here. You will realize that the total is not 255 because we only have 3 ones. The remaining 5 are zeros. So to know the total of these 3 ones, remember I told you any of these numbers correspond to 1 in this list you are seeing here. So the first one is 128 plus second one is 64, then plus the third one is 32. So to get the number that is, to get the mask number here, which means we will add 128 plus 64 plus 32, which will then give us 128 plus 64, that is 192, plus 32, that is 224. So therefore, the subnet mask of this IP address here will be 255.255.255. So the subnet mask of this IP address here now will be 255.255.255.224, which is written as. Let me give you another example using the same IP address. This IP address here is the one I placed here, but the difference is this one is /15. Remember, this is /27 and this one is /15. Now let's work on this /15 to know what our subnet mask is going to be. The same thing we need to do. Let's write all the 32 bits also. We have 8, 16, 24, 32. We have the complete 32 bits. Here now we are told 15. We are told 15 bits belong to the network ID, and then 17 belongs to the host ID. Let's highlight the 15 that belongs to the network. We go 8, 9, 10, 11, 12, 13, 14, 15. Okay. So these are the ones belonging to the network ID. We highlighted the 15 now, which belongs to the network, and then the rest are for the host ID. Now let's try to convert these 32 bits into binary. So all the 15 that belongs to the network ID will be written as ones. Yeah. Then the remaining will be 0. So now this is 0. All the rest will now be 0. We are writing the binaries. Anyone belonging to the host, we write it as 0. Okay. Now we have 15 for the network and 17 for the host ID. Remember, in the previous example, I told you in any one whereby all the ones are turned on, the total is 255, which is by adding these numbers. Each of these numbers correspond to the numbers here. So here we have 255. Okay. Then when you come to the second one, you realize that we cannot have 255 because one of them is 0. So to know the mask number here, we will be adding all these except the last number. Like I told you, the first one corresponds to the first one, second to the second, fifth one here to the fifth one, and like that. So to get the number here, we will add all these except the last one, which is 0. And if you look at here now, the last number here is 1. Now, which means we'll be adding 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 to give us the number that's supposed to be here. And now when you add all those numbers, you will now get 254 because the 1 is excluded. That one is 0 here. The 0 corresponds to the 1. We didn't include that one. So we have 254. Then aside from that one, all the remaining zeros, we just write 0 for them, wherever they belong to. That one is 0. And this one too is 0. Now the subnet mask for this IP address here, if you use /15 for it, the subnet mask will be 255.254.0.0. Sorry. Yeah. So you can see that we use the same IP address, but we got different subnet mask because of the CIDR notations. This one is /27 and this one is /15. So you can see any number slash any number ranging from 0 to 32. You can be given anyone, and each number is unique. But if you follow the example, you will get it right. I'll make a follow-up video to explain how to find the network ID, broadcast ID, and the usable IP ranges. Yeah, let's look forward to that one. Thank you very much.